Hello, and welcome to Bytesized Godot, a series covering technical aspects and development tips for the Godot game engine. I'm Bryce Dixon, a professional game programmer with over a decade of game development experience ranging from solo projects to AAA studios. In this video, I wanted to briefly cover how signals and coroutines can be used to streamline your project and clean up unnecessary or complicated code. Here's an introductory example. In this case, the f function is a coroutine, which depends on our sum event signal to finish. A coroutine basically being any function containing the await keyword. We can see that even though all of the prints in main happen after f is called, f's second print message doesn't occur until the signal it's awaiting is emitted. This is much cleaner than, say, checking if some condition is true in a node's process function, and can be very useful for ensuring certain steps of a process are completed in the correct order before we continue. We're also able to provide parameters to signals which are given back to anything awaiting them. And if we give multiple parameters, anything awaiting that signal will get them joined into a single array. In this example, I'd like my A class to get a properties value from its sibling B in its ready method. But this value is only initialized after B has finished its own ready call. The solution with signals is quite straightforward. We check if B is ready and simply await its ready signal if not. Coroutines do raise one issue, however. Since coroutines aren't guaranteed to finish on the same line that calls them, how can we get their return value? We can see here that we aren't able to capture the return value of f directly for this exact reason, but thankfully the engine tells us that we can simply add a wait to ensure the coroutine finishes before we try to store its result. The other way we can use signals is by explicitly connecting functions to them ahead of time. We're also still able to add parameters to our signal, which is then passed to the connected callables. At first, this might seem like a very convoluted way to call functions, but it gives us two very important benefits. First, we can set up these connections in the editor under the node window, which is in the top right by default. Second, we don't need to know exactly what should happen when our signal is emitted, just when it should be emitted. These two factors combine to allow us to write far less code and sometimes avoid writing code altogether. For example, we could have a signal that's emitted whenever a character is damaged. Then different results, like visual and sound effects, could be triggered by connecting to the signal rather than needing to write new or update existing code. Here I've created a simple example where a button being pressed causes a label's text to update. This is done without writing any new code, and instead by connecting the button's pressed signal directly to the label's setText method, as Godot allows us to bind and unbind parameters to the callable being called by that signal. Every node type has useful signals which can be connected to for very dynamic behavior, so I'd recommend checking the documentation for different signals you might find useful in your project. Thank you for watching. As always, I've left links to relevant documentation in the description for further reading. If you'd like to suggest a topic for a future video, please do so at the list linked in the description.